Okay, this is MAP4C, day 13. The lesson is 2.2 design problems. And this actually, today's lesson uh, will be revisiting questions from the first two sections of the geometry unit so far. And so this is kind of a catch-up day, and we'll see the types of problems that we're asked to do are, I think, interesting. So today's goal, to solve problems involving measurement and geometry. And the 3-minute review question says, a golf ball has a diameter of 44 millimeters. Design a package that holds 3 golf balls. And we've seen, well, any golfer, I suppose, has seen these packages. Usually you stack them on top of each other, kind of like a snowman, like this. The point that I want to make here is that, back in grade 9, usually we just say, okay, each one's 44 diameter, so we go 44 times 3 and get an answer, and we'd know the length of the package, and then we could figure. What I want to talk about today that's a little bit different is this idea of 44 is not a very good choice, because if I built a box around this, it would barely fit. And of course, we want to be sort of a little more practical in our course and, design things that we could actually use. So instead of 44, I'd say we'd want to use maybe a box that's 45. Each ball is 45, because then we've got a little bit of room for error, both in the manufacturing process, in the packaging process, and the shipping process, all that sort of thing. Instead of having the ball touch the outside, that can probably cause all sorts of problems. So I'm going to say, if this is the box here, oops, that's okay, we'll get by, that instead of 44, that we have a few millimeters of wiggle room in here, and then this would be 45 and 45, so the ball doesn't get stuck getting put into the package, so there's a little bit of wiggle room. But still, we wouldn't want this to be 50, because that would be wasting packaging. Here in the question, it looks like that's all we needed to do, is just essentially draw this picture. I'm going to do a closing sentence in a second, but you can see what's going to happen in the lesson is we're going to be asked to find the volume of this box, or how much packaging it'll take, or whatever. So I'm going to write my sentence. The box could be, or should be, 45 millimeters by 45 millimeters by 45 times 3 is 135, 140 or 135 millimeters. Okay. And this is the type of question we're going to be on to, and actually there's only one example, but it's a pretty good example. To solve design problems involving the volumes of composite figures in real-world applications. So these problems that we're dealing with today are very practical in nature, and we're going to have to make some design decisions. Not all the information is going to be given to us in the question, as we'll see right away. A DVD spindle will hold 100 DVDs. We've hopefully have all seen these before. The base and spindle are made of solid black plastic. So this part and the spindle are solid black plastic. And it says the radius of the base is 2 millimeters more than a DVD, and the base is 8 millimeters high. So notice that a lot of the information is not given. We're going to have to get out our ruler and measure some. So of course, I'm going to have one of these available for you to check out measurements in class, that sort of thing, but you're going to have to trust my measurements and check them tomorrow in class. What volume of black plastic is required? Notice there's a magic word. We're going to be finding volume. And so if we think of the black plastic, it's the base and the spindle, isn't it? Right? And not much of this is given. The only thing that's given here is that this has got to be 8 millimeters. That's 8 millimeters high. And it also says the radius of the base is 2 millimeters more than a DVD. How much is a DVD? Well, we don't know. We're going to have to actually measure it, and you should go through this process of measuring. You will for the homework. So, but I made some measurements. You can check mine and argue with me later if you like. I found that the diameter all the way across one of these DVDs or CDs, I guess they're almost the same size, was 12 centimeters, which means the radius is what we want, is 6 centimeters. The hole of a DVD, which notice the hole is going to give us how thick the spindle needs to be, was 15 millimeters. Now the thickness is a strange thing, because when you think of the thickness of a DVD, it's kind of hard to measure one, unless you got a tool from Mr. Collins' manufacturing class, or I suppose you could look up all this information on Google. I bet you somewhere they'd have the dimensions of a typical DVD, but when I'm just using my plain old yellow ruler, it's too hard to measure one. So I put 10 together and found that that was 14 millimeters, about. And so if I wanted a stack of 100 of them, I didn't want to count to 100, so then I just multiply by 10, 140 millimeters. And that's going to determine some of the measurements that we're going to need. Now, the idea of the composite shape, well, what do we got here? This is not very difficult at all. It's just two cylinders of different size. We got the spindle, which is a cylinder. The radius of the spindle, well, the radius, the hole is 15 millimeters. Now notice we don't want the radius to be half that, because the DVDs won't fit on there very nicely. So we're going to go a little bit less than that. We're going to go, the radius is not 7.5 millimeters, but 7. And that, notice that also saves us a little bit of material too. I'm going to actually change that to centimeters. Some of my dimensions are in centimeters already. And the height of the spindle is the 100 DVDs. But notice that if we made it exactly 140 millimeters, that the top DVD might not fit on there very nicely. So probably we want a little bit of extra so the top DVD doesn't fly around, that sort of thing. So I'm going to add, we could add 1 millimeter. I'm going to add 2 millimeters just for, and this is what I'm talking about our design decisions. And that was the expectation, was a design problem. And those of you that have taken Mr. Edwards' class, you guys make these decisions all the time. And so now it's just math, right? 7 centimeters squared times 14.2, and I got the volume is about 21.9 centimeters cubed. And hopefully you got enough room to handle this. We got to do the volume of the base now, but it's just a cylinder as well. And the radius, well, it says the radius of the base is 2 millimeters more than a DVD. Well, the DVD radius was 6 centimeters plus 2 more millimeters. Well, 6 centimeters is 60 millimeters plus 2, 62 millimeters. And the height, well, that was one of the only things that was given in the question, was 8 millimeters, which is 0.8 centimeters. 62 millimeters is 6.2 centimeters. Notice, so I've changed everything into centimeters over here, so I'm going to stick with that. That goes into a calculator, and you get about, all these are approximate answers, measurements, estimates, all that business, is about 96.6 centimeters cubed. Then the total, add those two numbers up, add that number and that number up, and you get 96 and 21 together is over 100, 118.5 centimeters cubed about. And then of plastic, so how this is made, probably some sort of machine that would inject liquid plastic in and spit out these spindles, these bases. That's one piece. And the second piece is this clear plastic thing. And it says what area of clear plastic is required. So probably, since it's an area question, it's a different process. It's probably not this clear part, probably not made with a mold, but maybe it's stamped out from a big sheet into these shapes. And in fact, I worked several years ago at Fram, now closed down in Stratford, and they made filters for cars, oil filters and air filters and that sort of thing. And the can part, the outside of the filter, was made exactly in that way, not with a mold, a metal mold, but they were stamped out from a sheet of metal. And so probably that's how this outside is made. But for us, we just want to find the area. And notice the outside part, it's just the top and the curved part. There's no bottom, right? There's no bottom here. So when we look up our surface area of a cylinder question, it's just one circle, not both of them, plus the curved part. The radius from earlier was, well, and again, there's a design decision to make. Is this, this one looks like it's got a bit of a lip on it, doesn't it, between the clear plastic and the black. I've seen the other ones where it goes straight up, and that's what I'm just going to use 6.2 centimeters. And the height, well, the height's got to cover the spindle, right? And notice the height here of the spindle was 142 millimeters, but if I made it exactly the same amount, notice it would kind of sit on the top and wouldn't quite make it down to the bottom. So I need the height of the clear plastic part to be a little bit more, maybe another millimeter more or 2 millimeters more. I'm going to say 14.3 centimeters, and that way there should be a little bit of clearance up here and still reach the base. And then that goes into a calculator. That can go into a calculator all in one step, and you get about 6778 decimal, or 677 decimal 8 centimeters squared, and that's the area. Okay, that's it.